In this variation of a problem we did in the first two parts of the video, we're trying to find the minimum launch speed needed in order to clear the uprights. So as opposed to finding how much it'll clear the uprights by, we're now trying to find that initial velocity. So again, if I redraw my diagram, you have a ball leaving the ground. It's going to leave at an angle of 50 degrees. So we know that's 50 degrees. And some velocity, let's just call that v. And it's going to come through on a parabolic trajectory. Now, if it's just clearing the uprights, we're going to assume that it's passing the uprights right at that position. So it's going to have a position right here, and those uprights are located at a position that's 52 meters away, and they are elevated 3 meters up based on what the problem says. So they're basically giving us our initial and final positions in the x and the y direction. And so when I set up my xy table, in the x direction, the acceleration is always 0. You have some time it's going to be in the air. You have a velocity in the x direction. Initial and final are the same. You have an initial position in the x, which is 0 meters. A final position in the x, which is how far away the goalposts are if you kick at the minimum speed. And in the y direction, you have the acceleration, the y is negative 9.8 meters per second squared. You have some time in the air, which is the same time that it travels in the x direction. You have initial velocity in the y, a final velocity in the y, an initial position in the y. It starts on the ground, and it finishes at an elevation of 3 meters if it just passes the upright. So this is a ball that's going 52 meters in the x and 3 meters in the y. And so we're really trying to evaluate what v is. And what's tricky here is in a normal problem, we would break down that initial velocity into components. You have the velocity in the x, and you have the velocity initially in the y. And when we do this, the trig tells us that the velocity in the y is going to be v sine of the angle theta, and the velocity in the x is going to be equal to the velocity, the hypotenuse, times the cosine of the angle theta, which in this case is 50. I'll start it in this theta here. The problem here is we don't know what v is. And when you don't know what it is, then we want to keep it as a variable. And so in my table, rather than writing in actual values for vx and viy, I can write it in as v cosine 50 and v sine 50. And if that's the case, I can write a position function using this equation for the x and the y direction. And because I've written those initial velocities in terms of v, I'm going to get a system of equations with the same two unknowns in that equation. And so I'm going to set up my x and y equations. In the x direction, you have x final is 1/2 ax t squared plus v initial in the x t plus x initial. And again, because a is 0, that always goes away. It just becomes your constant velocity equation. And I can write out what I have here. That's going to give me 52 equals v cosine of 50 times t plus 0. So I have an equation with v and t in the x direction. And in the y direction, I would have y final is 1/2 ayt squared plus v initial in the yt plus y initial. And my final position is going to be 3 meters. Half of negative 9.8 is negative 4.9 t squared. Plus my initial velocity in the y direction is going to be v sine 50 times t. And plus my initial velocity position in the y, which is 0. And so what I have here, two equations. I have an x equation and I have a y equation, both of which had the same two variables, v and t. And so we have a system of equations with the variables v and t. And if I can solve that system and solve for v, I now know that minimum velocity needed. And so now it's an algebra problem. And when you go back to your algebra class, we learned multiple ways to solve systems. And one of the most common ways that people use is to solve by substitution. And that's how I would recommend doing this, although you could solve by elimination, and that would be probably the next best way to solve it. So if I'm solving by substitution, we're going to look at either equation, and we're going to solve and try to find one of these equations in terms of the other variables to then substitute. I'm going to solve by substitution. And so my first step is to take either equation, and if you look at the equation on the left, it's a little simpler. And I'm going to solve that first equation for either v or t. It really doesn't matter. And whatever I solve it for, I'll take that amount and plug it into the second equation. Now, when I look at the second equation, I have a t squared and a t, and I have just a v. So to me, when I look at that, if I can solve the first equation for v, I only have to plug it in one spot. So I'm going to take the equation, and I'm going to solve for v. And in order to do that, I'm going to divide by cosine 50 times t on both sides. And so I get an equation, a new equation that says v equals 52 divided by cosine of 50 times t, all in the denominator. And I can take that value and plug it in for v in the second equation, in our y equation. And so I'm going to take my equation I have up here in the red brackets, and I'm going to get 3 equals negative 4.9 t squared plus v, which is 52 over cosine 50 times t. That's what v is. And that's going to get multiplied by sine 50, keep that in black, times t. And now I have one equation with only the variable t in it. And if you notice, right away I see that the t here cancels. Now, if you Google and try to solve this problem, you're going to probably see some crazy function with tangent in it. Well, it turns out sine of 50 over cosine 50 is the same as saying tangent of 50. For our purposes, I'm just going to look right here and start to calculate, because sine of 50 is a value between 0 and 1, and cosine of 50 is another value. So I'm going to start to simplify to solve this. So I'm going to take this whole term on the right, and I have 50 times sine of 50, and I got to make sure I'm in degree mode, and then I'm dividing that whole thing by cosine of 50. And I'm going to need a value for that part on the right of 59.59. So I'm going to get 3 equals negative 4.9 t squared plus 59.59. So I basically simplified that 52 sine 50 over cosine 50 down to a number. And now I have it a function with just t squared. And again, if I did 52 times tangent of 50, I should get the same thing. Sine over cosine is tangent. And I didn't get that. I'm trying to find where my mistake was. Oh, my calculation above, I see I made a typo. If I hit second enter, I had 50 in there, and that should have been 52. There we go. Should be 61.97. So let me fix that. It's always good to check your math. If you were doing a WebAssign problem, it might have kicked you out and said you're wrong, and you'd be pretty frustrated right now. 61.97 is the actual value. So now I'm just solving for t. I can subtract 3 from both sides, and I get 0 equals negative 4.9 t squared plus 58.97. And let's get the t Turn around the other side, add 4.9t squared to both sides. Now it's just an algebra problem. I get 4.9t squared equals 58.97. I'm going to divide by 4.9 to get t squared by itself. I get t squared equals, let's subtract 3 from that, and then divide by 4.9, 12.03. And to get t, I got to remember to take the square root. And so I'm going to get a time when I take the square root of that value, second square root of that answer, of 3.47. 3.47 seconds is how long it will take to get to the uprights at our minimum speed. But I want the velocity. So I'm going to take this time, and when we solve a system, you can sub it back in to the original value into either equation. Well, I have an equation solved for v already. So I'm going to plug it right in here and calculate what my v is going to be using that time. So v is going to be equal to 52 divided by cosine of 50 times my time, which is 3.47. Plug in my calculator, 52 divided by cosine of 50 times answer I just got, and hopefully my parentheses are right, and I get 23.32. So my velocity is 23.32 meters per second. So that would be the speed needed, the minimum speed needed to kick the ball through the uprights. Hope this is helpful, and hopefully you can follow my algebra as we solve a system of equations. And this is really as tough as any of our problems are going to get in this class. We're applying the same principles, except when we're missing v, we just have to treat it as a variable and follow the same steps we've done before and carry that v all the way through, do a little algebra, and hopefully get to the solution you want. Have a good one.